Hello, everybody. It's Mr. Millington here. In this video, we are talking about volume. We're talking about volume of prisms and cylinders in this video. So you've probably heard about volume in math class before. In geometry here, we think about it as like the space occupied by a three-dimensional object, and we measure volume in cubic units. So we've been doing a lot of things with area. We've been studying surface area. So area you think about as how much space is kind of covered by a two-dimensional shape, a two-dimensional object. So volume, we're going into 3 dimensions. And again, we're using cubic units, whereas with area, we were using square units. So let's go ahead and look at an example. Or actually, before we do that, let's talk about, what is a prism? So a prism is a shape where you've got two bases and they're the same on the top and the bottom. So in this picture of this fish tank, this is a rectangular prism, right? We've got a rectangle on the bottom, we've got a rectangle on the top, and they're parallel to each other, they're congruent to each other, and then it's got a height to it. So this is a cylinder. It's technically, I guess, not a prism, but it works just like a prism because we have the two bases, which are circles. There's a circle on the bottom, a circle on the top. They're parallel to each other, and then there's a height in between those two bases, right? So there's all different kinds of prisms, and let's take a look at a video really quick to kind of illustrate what volume looks like. Okay, so if you look at this, there's a tank in here. It's being filled up with water. The bases on this are octagons, so this is like an octagonal prism. And you could figure out the area of that octagon on the bottom, right? But then what's the volume? Well, the volume depends on how tall that this prism is, right? And so with this water, you can see like the volume of the water will obviously increase as the water goes up. So when, if you first start here, the volume of the water is very low as it's just like splashing over the bottom. But as it fills up, the volume of the water will get bigger and bigger till it reaches the top. So again, volume is just kind of the amount of space that something is taking up, and it depends on the shape of the base, and then the greater your height of that shape, the more volume you're getting. So that might just help us think about like how we treat volume when we're finding volume in geometry. Okay, so let's take a look at this example. So sketch out this cylinder real quick. The bases on a cylinder are circles, so I want you to do a quick RDCA. And radius is 3, diameter is 6, the circumference is 6 pi, the area would be 9 pi, right? All right, so how do we find the volume, right? We know the area of the base, we know the area of this circle on the bottom, or the area of the circle on the top is 9 pi, right? So if you could imagine like water filling up this cylinder, like it'd be 9 pi is just like is the area of the base. But then as you keep filling up higher and higher, the volume just keeps increasing. And then the volume of this whole cylinder is, well, what's the volume if you take it and you go all the way up to 10 inches? So all we really have to do to find volume of a prism is you take the area of the base, and then you multiply that times the height of your prism. That's the formula for volume. Now, we don't want to write area of the base every time. So in geometry, we use this like uppercase B to represent the area of the base. If you actually look at like a geometry textbook, you'll see like a big B. It's usually kind of, I don't know, italicized or just looks fancy like that. So area of the base, right? That's what this is. Area of the base is this B. And then we just multiply times the height. So area of the base times the height. That's your volume formula. So back to our example here, we've got volume, the area of the base. Well, my base was this circle that was 9 pi, right? So my area of the base is 9 pi. The height of my cylinder is 10. So 9 pi times 10 would give me 90 pi inches cubed. That's my volume of this cylinder. All right, let's do one more example together. Okay, so this says find the volume of the regular hexagonal prism. So the bases here are hexagons, right? So this hexagon here, right? Think of that as one of the bases. So that's like, we have to find the area of this base. So, so the bases are the hexagons, which I'm writing this out because that can be confusing because sometimes people think base, they think that has to be like what's on the bottom. And the way that this is drawn, the hexagons are not drawn on the bottom. They're kind of drawn like facing you, right? And then it looks like this rectangle on the would be the bottom. But really, when we're talking about prisms, when we're talking about three-dimensional shapes, when we're talking about prisms like this, the bases are the congruent shapes that are parallel to each other. So in this case, that's two hexagons. We got a hexagon in the front, we got a matching hexagon in the back. Those are the bases. So again, for volume, we're going to do the area of the base times the height. So we have to find the area of this hexagon base. All right, well, how do you find the area of a hexagon? Remember, you can split them up into 6 equilateral triangles. Find the area of one equilateral triangle and then multiply it by 6. So these are equilateral. So you remember when you drew that, when you split it up like this, this creates, when you drop the height in here in this one triangle, that creates a 30, 60, 90 triangle. If you want to review this with me or Miss Rose, definitely let us know. It's something we did a while ago. So you're breaking this into a 30, 60, 90 triangle over here. Let me draw that 30, 60, 90 triangle. Or let me draw the whole equilateral triangle. So you've got the equilateral triangle. You're splitting that up. This is a 60-degree angle because that's equilateral. You've got 8 was the whole base. So when you do that, when you're kind of like cutting it in half here, this is 4. And then because of a 30, 60, 90 triangle, you're going to remember that this height is 4 root 3. So the area of the triangle is base times height divided by 2. So 8 times 4 root 3 divided by 2. 8 times 4 root 3 divided by 2 is going to give us 16 root 3. So that's the area of one triangle, right? The base was 8, the height was 4 root 3. So the area of this whole triangle is 16 root 3. But there's 6 of those. So the area of the hexagon, you're going to multiply that by 6. So 16 root 3 times 6 is going to give us, I think that's 96 root 3. Let me double check my work. Yeah, that was 96 root 3 for the area of the hexagon. All right, now going back to volume. Volume is the area of the base times the height. Well, we just found that the area of the base was 96 root 3. The area of the hexagon was 96 root 3. So our volume is going to be 96 root 3. And then the height is like the length of the rectangles that are connecting the two bases. So in this case, the height is 18. So 96 root 3 times 18 is going to give us a total volume of 1,728 root 3. And that's going to be inches cubed, cubic inches there. All right, thanks a lot for watching. Definitely let Miss Rose know if you have any questions, and we'll talk to you soon. Bye.